Warm up for lesson 6-6. Pause to do the problems. Here are the answers. Pause to do the problem. Here are the answers. Pause to do the problem. Here are the answers. Lesson 6-6, Rational Exponents. Objective: write expressions with rational exponents in radical form and vice versa. Simplify expressions in exponential or radical form. Let's take a look at this expression. This is a brand new one. We have a fractional power instead of an integer, and we're taking it to the second power. Second power means that we're going to have two of them being multiplied, two of the same thing. Now remember, in our exponential rules, when the bases are the same, you just add the exponents. So that's what we're going to do right here. We're going to add the exponents, and when we do that, that'll become 1, and then this is b. Well, that's interesting. B means that these are inverse operations, and a squaring process and a square root are the inverse operations. So that must mean that this fractional power is a square root, which that's what it is. So when you have b to a fractional power, like 1 over n, then it's the nth root. In this case right here, 27 to the 1/3 power is the third root of 27, which is 3. This expression, -16 to the half power, is really the same thing as the square root of -16. Let's go ahead and practice some of these problems. X to the 1/6 power is the 6th root of x. The 4th root of z is z to the 1/4. So we're going back and forth from radical form to exponential, from exponential to radical. So let's go now to radical form. So this would be the 5th root of a. In this expression, this is a root. We want to change it to exponential form, so it's c to the 1/8 power, the fractional power. In this case, our fractional power is 1/4. So this is the 4th root, because that's that 1/4, and then we'll have d to the 7th power. Over here, the root is 3, which means a 1/3 power. So this will be c to the -5, and then we're going to have 3 down here. So we go back and forth. Pause to do the problem, and here's the answer. Pause to do the problem, and here's the answer. Let's take a look at expressions that are a little bit more involved. In this expression, we have 81 to the -1/4. Well, let's go back to our properties of exponents. B to the negative n power is the same thing as 1 over b to the n power. In other words, cross the fraction bar to get the exponent to be positive. And that's what we're doing here. We're making it go to the denominator, and now it's a positive 1/4 power. Well, 1/4 is a 4th root, and if we take the 4th root of 81, the answer is 3. In this expression over here, it's to the 2/3 power. So let's go ahead and take the 216 and rewrite it to 6 to the 3rd power. Why the 3rd power? Well, because I'd like to see a 1/3 power and a 3 power reduce, and I'm having a power to a power situation, so I'm going to multiply these two numbers, power to a power. This will be 6 squared, and the answer is 36. Now we can also do this on our calculator. Let's go ahead and I'll show you how to do that. 81 caret, and then we're going to write -1 divided by 4. And that'll be the -1/4 power. And if you enter it, you're going to get 0.3 repeating. We can change that to a fraction by pressing math and then entering, and it'll change our answer into a fraction. Enter once again, and we'll get 1/3. Now you can do the same kind of thing with that 216 to the 2/3 power. 216 caret to the 2/3 power, and go ahead and enter, and you'll get the answer that is in here is 36. So these can be done on the calculator, or can be done with the properties of exponents. Pause, and here's the answer. Pause, and here's the answer. Let's go ahead and take a look at more complex rational exponents. And so exponents that are not just simple like 1 over 3 or 1 over 2, but x over y. And when you do that, what we can do is we can write this expression in two ways. So let me go ahead and take a look at a number right here, like 27. 27 to the 2/3 power is the same thing as 27 2 times 1/3. So what you can do is you can put the 27 squared and put the 1/3 power out. Remember, power to a power as long as it's 2/3. Or you can put the 1/3 power inside the parentheses and put the 2 outside. As long as these two numbers multiply by 2/3, you can go in whatever order you want. In this case, they did the 1/3 power, or the cube root, inside, and when they simplified, they got the number 9. So you can go either way when you have these fraction exponents. All right, so let's go ahead and take a look at other rational exponent simplification. We have two bases that are the same and our exponents are different. Remember that our property says if the base is the same, you just have to add the exponents. So that's what we're going to do here. We're going to add the exponents. That's going to make 6/7, and here's our answer. All right, here's a -5/6. Put it to the denominator. That's our property here. And we do not want to leave a fractional exponent in the denominator. So what I'm going to do is multiply by b to the 1/6. Why the 1/6? Because when these two add together, it'll be 1. But whatever you do to the denominator, you must do to the numerator. So I'll have that expression in the numerator, and I'll have b to the first power in the denominator. And now there's no longer a fractional expression in the denominator, so we call that standard form. All right, let me go ahead and do some problems. And all I'm going to do is add the exponents since the bases are the same. So 1/4 plus 9/4, and the answer is p to the 10/4. I'd like to reduce that fraction to 5/2, and then we're done. I want that not to have a negative exponent, so I'll have it 4/5. Now I'm not allowed to keep a fractional exponent in the denominator, so I'm going to multiply by r to the 1/5. Why? Because when I add these, it'll be 1. But whatever I do to the denominator, I must do to the numerator. And so my expression will be r to the 1/5, and then this will be r to the 4/5 plus 1/5. This will be r to the 1/5, and this will add up to 1. And I'm not going to put a 1 right there. And that is a good standard form there where we don't have a fractional power in the denominator. Pause. And here's the answer. Pause. And here's the answer. Let's take a look at expressions that are a little bit more difficult. We have a 4th root in the numerator and a square root in the denominator. Let's make them into exponents. So we have these exponents. Now 27 can be rewritten, and we'll write it as 3 to the 3rd power. Now this is a power to a power, so just multiply the 3 and the 1/4. And we have the 3 1/2. Now we have the same bases, so we're going to take the exponents, so we're going to subtract the numerators, exponent minus the denominator. So I'm going to go ahead and do that, and I get that as my answer. And remember that fractional exponent is just a root. Let's take a look at this expression right here. I'm going to change it to the 1/3 power. 64 can be written as 8 to the 2nd. And then I'm going to use this property of exponents. Whatever's inside, take each one to the exponent here. And so we're going to take 8 to the 2/3 to the 1/3, so we'll have that here. And then z to the 6/3. That'll simplify here. And 8 to the 2/3 power will be equal to 4. Why is it equal to 4? Well, because I can take the 3rd root of 8 and then square it. So this will be 2 to the 2nd, which will be 4. Okay, let's go ahead and practice these problems. I know that this is going to be 32 to the 1/4 power, and this will be 2 to the 1/3 power. Now I know that 32 can be rewritten, and it can be rewritten as 2 to the 5th power, and this will be 2 to the 1/3 power. So now I have power to a power. So that's going to be 2 to the 5/4 power all over 2 to the 1/3 power. Now I can subtract these. 5/4 take away 1/3. Now I need a common denominator, and that'll be 15 over 12 minus 4 over 12. And then that'll be 2 to the 11 over 12. That's the power I have. Okay, over here, this is going to be 16x to the 4th to the 1/3. Now I know that 16 is 2 to the 4th. And now I'm going to do a power to a power on each one. So this is 2 to the 4/3 power, x to the 4/3 power. And I can leave that in that expression. Okay, pause. And here's the answer. Pause. And here's the answer. And to match with what I have there, I have to take 2 to the second to the, I need to make that 1/3 power into a root right here so that I can match one of my expressions there. Okay, and at the end, this is a summary. We don't want to leave any negative exponents in the expression. We don't want to leave a complex fraction. In other words, we don't want a fraction over a fraction, and we don't want to have any kind of radical. We want the radical in the least number expression, and no exponents that are not positive integers in the denominator. So no fractional powers in there.